All right, what's going on, everybody? Today we're going to be doing another LeetCode video. This problem is called daily temperatures, and we're going to be doing it in C++. So let's just get into it. So we're given an array of integers called temperatures, and temperatures represents a list of daily temperatures, and they want us to return an array answer of equal size, such that each element in the answer is the number of days you have to wait for the ith day to get a warmer temperature. And if there is no future day for which is possible, just set that element to 0. So what do they mean by this? Basically, let's just look at the input output. So we're given just this list of or array, really a vector, but so a list of temperatures for us, some days, and basically what they want is an output array where you're looking at each day and you're saying, okay, well, how many days is it going to take to get another even warmer day? So for 73, it's only going to take 1 day, because you can see the next day is 74. So the output there will be 1, or the element there will be 1 in the output. So likewise for 74, the next warmest day is going to be 75, so it's just 1 day away. For 75, we're gonna have to wait a little bit. 71 is not warmer, 69 is not warmer, 72 is not warmer, 76 is warmer, so it's 4 days away. And then for days when there's no warmer day, so like these last two elements, and especially the last element in pretty much every one of these inputs, obviously there can't be a warmer day after the last element. So they just want 0 in that case if there's never going to be a warmer day. So you can imagine like a naive approach for this problem would to just be use a nested for loop, right? And then at each element, you're gonna look at the rest of the elements and just see how far away the next hottest element is. So a nested for loop, and then that's just gonna be big O of n squared time, which isn't very good considering we can solve this in linear time. So the optimal approach is going to be use a stack. So that's going to be the data structure for this problem. We're going to be using a stack basically to remember days that we've already seen, and then like set those days. Like at each element, we're going to look in our stack and see if we can set the previous day's temperatures that are in that stack, based on how hot it is on like the current day. So use a stack. Hopefully that makes sense. I'll run through the algorithm to try to explain it a little better. So we're going to use a stack. The time complexity with the stack is going to be linear, so big O of n, and then the space also is going to be linear, because the stack could potentially have, if the days keep decreasing, then the stack can fill all the way up, in which case it would be linear time or linear space in the worst case. So let's just go over to this algorithm to kind of see how it's going to work. So I'm just going to copy this example here. So we've got that for the input, and then we have our output array here, which I'm just going to set all of these to 0 as I go through the algorithm, and then just populate them as we go. So, okay, so, all right, and then I'll just pretend we have a stack here. It's in brackets, but this will be our stack, where the top element will be the last one. So basically for this algorithm, at each element, we're going to insert it into the stack every time. But before we do that, we're going to check if the stack has elements that we can set the temperatures of for. So the first thing we do at each iteration is we check, does our stack have stuff in it? No, it doesn't. So we don't do anything there in terms of updating the result, but we're going to add 73 to the top of the stack. Okay, so for the next element, we check if there's stuff in the stack. There is. now we're going to try to set the answer here for 73. So, and to do that, we're just going to ask, is the temperature of the current element we're at greater than the one at the top of the stack? Yes. Well, we know now that this element, we can just do the math there for the indices and see that it's 1 day away. So this is going to get set to 1, and then we pop that from 73 from the stack because we're done with it. Okay, so now we add 74 to the stack, because remember, we do that for each element. So at 75, we're going to see if there's anything in the stack. Yes, there is, and 75 is greater, so this is going to become 1. And then we pop 74 from the stack and add 75 to it. Okay, so now we're going to look at 71. Is 71 greater than what's at the top of the stack? No. Okay, well, let's not do anything. Let's just add 71 to the stack then. Now we're going to move on to 69. Is 69 greater than what's at the top of the stack? No. So we're going to add that to the stack. Okay, now we are at 72. 72 is greater than 69, so we can set the answer for 69. Now, how many days away is that? It's only 1 day away, so that's going to get set to 1. We're going to pop from the stack, but this is going to be a while loop, so we're not done yet. 72 is also greater than 71. By how many days? By 2, so we can set that answer to 2. Pop that from the stack. 72, is that greater than 75? No, it's not, so we're going to add 72 to the stack. Okay, now we can go to 76. Is 76 greater than 72? Yes, it is. So we can set that answer for 72. That's going to be 1 day. We can pop that from the stack. Is 76 greater than 75? Yes, it is. And how many days away is that? It's 1, 2, 3, 4 days away. So this answer here is going to be 4. And then we can pop that from the stack. So now we get 76, because that's the element we were just doing, so we add it to the stack. Is 73 greater than 76? No. So we're going to add it to the stack. We're not going to do anything. And that's going to be pretty much the end of the problem. Both of these are going to stay as 0. And as you can see, our output array is pretty much exactly the same as what it shows there. So that's pretty much going to be the algorithm. So now that you kind of hopefully understand better, I did go through that kind of quickly, but hopefully that kind of makes more sense now, and then maybe it'll make even more sense once I write the code. So the first thing we're going to want is just a vector of integers for our answer, and remember, it's going to be the same size as the temperatures array. So we can do that. We can set the size as the first parameter of the constructor, and then to set every element to 0 at first, because remember, if there's no greater temperature, they want it to be 0. So we can just set all of those elements to 0 like that with the second parameter of the constructor. We also need a stack, and that's just going to be of integers. The stack is going to store our indices, so I'll just call it indices. And then basically, I'll just use a C-style for loop to iterate through each number in the temperatures array. So I'll just copy that over to be a little faster here. Okay, so we're looping through every element in the temperatures array with a C-style for loop, so we have the index. So basically, at every element, remember, we're going to want to ultimately add the element to the stack, so I'll just do that first. To do that, we can do indices.push. We can use a push method to just push that index onto the stack. And then remember, we're doing a while loop to kind of check through the entire stack. So the first thing we want to check before we try to access the top element is see if the stack actually has stuff in it. So we can just call stack or indices.empty there, and then so if the stack is not empty, meaning it has stuff in it, and the current temperature, so temperatures I, if the current temperature's value is greater than the value of the temperature at the top of the stack, so remember the stack just has indices, so we need to index into it like so with the top value of the stack, so indices.top. So temperatures indices.top. So if the temperature at the current day is greater than the temperature at the top of the stack, then we can basically set the result array's index at, remember that's going to be the index of that value at the top of the stack. So, and then that is going to be to kind of compute the how many days it's going to be. We can just take the difference of those indices. So I minus indices dot top, and then remember, then after that we're done with that day, so we can just pop from the top of the stack. And then at the end of all of this, we're going to want to just return that result array. So that's pretty much it for the code here, unless I made a bug, which we can fix. Okay, so it looks like those initial test cases passed, so let's just go ahead and submit this to see our percentages. And looks like we beat 75% with runtime, 50% with memory, so pretty good solution. Hopefully this helped you understand this problem more. If it did, please leave a like and subscribe, and I'll see you guys in the next one. Thanks.